Hey everybody, today I'm going to do a little video on how to do precision two-sided laser work. Like if you wanted to cut through a material that was really thick, that was thicker than what your laser could cut through, it works for that. It also works for situations where you might, like say, cut through the material and then need to have some engraving on the other side that's precision aligned with the front side. For example, like if you wanted to outline a pattern or something, typically if you're trying to do that really close to a cutout, if it's off center just a little bit, it's very noticeable. So if you need precision alignment from the front side cut to the back, that's what this video is about. So typically when you do that with a spindle, you'll use the router or spindle and drill a couple of precision holes right through the stock into your spoil board, and you'll put some alignment pins, like a couple of 1/4-inch dowel pins, in those holes. And what that lets you do is put a reference alignment feature in the design file itself, like in Vectric or Fusion 360, and that way you can keep the same reference from the front to the back of the design within your design. Because if you for example you try to get the exact size of your material and flip it over and use the same corner, when you flip it you might use the lower left, and then when you flip it over and use the lower left again to align to, you're basically going to be doing two corners from one run to the other, and you're never going to get that much better than it's really easy to be off by 5 to 10 thousandths doing that. The best you'll usually do is get within a few thousandths of an inch, but even that will leave a pretty noticeable step between the front and the back. So generally what you want is a reference that's built into the design itself, not something that doesn't require you to do two X, Y, 0 resettings or something like that. So again, you can't use a dowel pin method with the laser, because in this case I don't want to cut all the way through with the laser, for one. So we're going to do something a little different. We're going to use we're going to basically make a template that's built into the design that has a reference on the left and the right, so that when we cut out of a square such as this, we can use this edge up against the template on the left side, and then when we flip it over, we can slide it over and use that same exact edge against the right side of the template. And as long as that template is in the design and is cut out in the same session, we're not going to change any of our X or Y zeros in the controller software. As long as it's done that way, and we snap the design on the front side to the left side of that template and on the back side to the right side of that template, we can get an exact alignment from front and back, within reason. Nothing's absolutely perfect, but in my first trial run I made a couple of these hearts. It's something that my wife and I have made for quite a few of our family members. We used to make these on a scroll saw, and cutting 3/4-inch oak with a scroll saw is kind of a pain. It's just slow going, requires a lot of sanding and stuff later. So I know I can cut all the way through 3/4-inch oak with my 45-watt op laser, but just kind of barely, and it cuts very good quality for probably 1/2 inch thick, and that last 1/4 inch it struggles because the beam is spreading out. So what I really wanted to do with this is cut halfway through on each side and kind of meet in the middle. So that again requires me to get fairly well aligned. So that was the goal here, and it actually worked out very well. The other nice thing with the laser compared to a scroll saw is that it leaves nice black char, the burning on the lettering, which helps really, I think, make it show up a lot nicer. So it looks kind of cool. These I sanded and took the black off the edges because I'm trying to match some other ones that I've previously made. However, if you're making these, if you don't need to match something else, they actually look pretty good with the black on the outside. So you can just do a light sanding to kind of get some of the charcoal off, and then coat it with polyurethane or whatever your favorite finish is, and that'll kind of seal it in and keep the charcoal from rubbing off on your hands, but it leaves kind of a nice accent on the edges there. So your choice, that obviously saves you a lot more time. I had to put these on the oscillating spindle sander and sand off all of that soot on the edges, so that made it a little bit more work. But doing this worked really well. It took the execution time from making these from a couple of hours down to like 10 minutes really if I were to leave the black on. So really good time saver. With this laser I could probably cut 1 inch. I know I could do 1 inch very easily of any hardwood. 1 1/4 probably would be pretty well, because that laser will cut any hardwood up to 1/2 inch very, very well. So this basically doubles your capability on cutting with the laser. So let's get in how we do the design work first in Vectric, and then I'll show the actual cutting process. All right, let's go through the design elements of how to make the front and the back etching or cutting sections, and how I make them so that they can align to each other perfectly when cutting the front and the back. So the first thing, so this is the front over here that's highlighted, it's enabled, and then the one that's grayed here is the backside cutting. You can see they're just a mirror image of each other. And the idea with this particular one is these are through cuts, and so I have set my laser, or I want to set my feed rate and my laser power so it cuts just a hair over halfway through. So to make that come out nicely, I need these cuts to align perfectly from the top and the bottom so that they meet in the middle just right. So I start over here on the right with the front side image. So this highlighted item is the actual project that I have. This is what I want to cut out. The square here is my reference frame for this project. They kind of go together. So this is essentially the size. This is my initial size of the blank of wood that I'm going to use. It's not so important that that's accurate, and you'll see why in a minute, but it does need to fit within this frame. It basically needs to be bigger than the object that you want to cut out, and it needs to be smaller than this other frame that we're going to talk about next. So after the project then is these two items are what I call an alignment frame. So this is something I'm going to put in this design, and I'm also going to cut this out. You can use a piece of MDF or plywood. In my case, I just like to use cardboard. That's cheap and it works just fine, and it cuts really easily, because we're just going to put that into or on the CNC and tape it down or clamp it down or whatever. But that's our fixed reference, and essentially what we have here is we've got a reference on the left side of the project in this frame, and we've got a reference on the right. So you can see on my top side project, I've slid this over to the left so that this frame is lined up, which is my material, is lined up with the left side of the alignment frame, or you could call this a jig too. So in the design, they're lined up perfectly in this corner. Then on the back side, you can see I've flipped it. It's in a mirror image. Both this item and this item kind of go together. So what I do is I group them over in the front side thing, and I copy all these elements over to the back side. And I leave the frame, these two pieces, I leave these grouped, and I've copied them over, but I don't flip them. They stay exactly that way because that frame is our reference and we don't want to move it. So I copy that piece over directly, and you can also see up here on the left, my workpiece size is essentially this cardboard, this overall cardboard frame size. So it's not the actual material I'm cutting in this case, it's the bigger frame or alignment jig that we're using. So I've copied over this rectangle as a group, and then I've copied over these two items, and it makes sense, or it works better if you group these so that you don't accidentally move. You know, when you move these two over, you do not want to move this inner
square versus the outer square rectangle. You don't want to move those in relation to each other. So it's good to move those over as a group. And you also don't want to move these two in relation to each other, because again, you're going to have to mirror flip those two together, and you'll only ungroup it when you go create the actual tool path. So in the creation stage, these two items should be grouped together, and these two items should be grouped together when you're moving from the front side to the back side. And you can see this, if I go back to my design work and the design type, this is still a single-sided project. And the reason for that is we're flipping this over, we're flipping the project over, but we're actually changing the orientation with respect to this frame that we're not flipping over. So we really want to treat this as a single-sided object. That's why we're doing it this way. So you can see I basically turn these others off. I have two projects in here. You can see basically I've created two single-sided sheets, but the external frame is a direct copy over, keeping the same orientation, and the material boundary and the project itself are copied over and then flipped over as a mirror image and shifted to the right. And so what you can see is that keeps the left side of this material bumped up against this left side. And then when I flip it over, this edge on the right is the same as this edge. So as long as I keep this project itself and the material boundary grouped and properly aligned on the left side for the front, and then over here on the right for the back side, I've essentially created a perfect reference for this frame that I'm going to cut out with the laser, and then the wood that I'm going to cut out with the laser within the design. So, I'll set my XY boundary down here in the lower left corner, like I always do, tape this piece of cardboard down, and then make a tool path. And so you can see, if I go to the front, you can see I've made a laser tool path for the frame, which is going to cut this hole out in the middle. And it's not really that important how accurate, this XY setting of my CNC control software is to this corner position, because if this edge is shifted over a little, it's also going to shift over the project itself. In both cases, the design stays relative to itself, I guess is the way to say it. The internal pieces are going to shift. And so the key is here, you don't want to readjust your X and Y zero position throughout this whole process. You're going to set it once up front before you cut out this cardboard. And then as long as you don't move that cardboard and don't reset anything, you can reset the Z for the material thickness, because you're going to have to do that. You're going to want to, the cardboard's thinner, and then when you drop the material in here, you'll have to set your Z height for the thickness of the wood once. But then when you flip it over again, you don't have to, because it's the same thickness when it's flipped either way. So that's really the process, is create the frame that's your reference, and then mirror image the design and go from the left side to the right side, so that the one edge of the wood is referenced to the design in each case. And that's all there is to it. When I did this, I got very good alignment. You could see a slight bump. Some of that's due to the laser beam spreading out and not being perfectly aligned in the middle. But the other thing I should point out here is that on the tool path for actually cutting through, I'm setting the speed and power and number of passes. I'm aiming to get just slightly deeper than halfway through the material. Turned out for this particular project, 30 was just slightly too high. Most of these pieces that I wanted to cut out actually fell out at 30, but a couple of them didn't. So I dropped down to 25 inches per minute on the next one that I cut out, and that worked a little bit better. But 2 passes at 25 inches per minute and 100% power easily cut through halfway on, so it's about, a little over 3/8 of an inch. Easily cut through that in 2 passes. It's a lot cleaner to cut it if you're moving faster. So it's not better if you were to like really overkill it and cut 90% of the way through from both sides. You'll just get more charring and stuff. So you really don't want to overdo it. The idea is to go as fast as you can and probably do a couple of passes on each side versus blasting it as deep as you can, going really slow. As I showed in one of my other cutting videos, you get cleaner results that way. So again, this is the target for, so a little bit of experimentation with the particular material to figure out how deep you need to cut, or how fast you need to run, and how many passes to get halfway through is good to do up front. And that's about it. So let's get into actually doing the cuts and see what the process looks like there. Okay, I've taped down my cardboard frame. This is just just one piece of, it's kind of double layer. It's heavy duty cardboard, but it'll make a good alignment frame. I've taped it down on both sides because I don't want this to move at all during the process. So now I got to cut the inner frame out of this. That's going to be the reference for the parts. The left side will be the reference for the front side, and the right side will be the reference for the back side cutting. So we got to cut that out first before we can proceed with the actual wood. All right, now we can start cutting the front side. So with the front side, it gets reference on the left edge to the left side of the frame that we cut. And then when we cut the back side, we're going to flip it over and reference off of this side. So it's important that you don't change your X and Y Z to this. We want to leave it exactly where it was with this cardboard cutout. When we cut that out, and everything, its reference point always stays relative to the things in the design. So we've cut the hole with respect to a spot in the design, and we're referencing this edge against that same edge, or that left edge. That's our reference, and then we're also going to reference it over on the right side. So all we want to do is set our Z height for the material thickness here, and we're going to run 2 passes on this on the front side, then we're going to flip it over and run 2 passes on the back side. So let's get our Z height set first. This is my new touch probe. I did a video on the installation of it, but I haven't done anything on the software. But I replaced the rod I used to have on the right side that I used with my electronic touch plate. Now I've hooked the touch probe in here, and I can flip it up out of the way, so I never have to go drag the touch plate out onto the surface. I can just probe it, and I'm using the same touch probe routine that AVID has in the screen. And then it's going to probe it, and in my screen I have an offset function to set the delta between where this probe finds Z0 and where my laser has the best focus for cutting. So I just have to run that, and then we're ready to run the G code. Alright, let's see how it did. Yeah, it fell right out just like it's supposed to. A little piece out, so this one says Dana, it needs a little sanding, but so the first one I did at 30 inches per minute, and that was a little bit too fast because the second pass in just a couple spots didn't quite make it past halfway, so they didn't quite meet in the middle. So a couple of the little pieces and the other one were hard to come out. So I slowed it down to 25 inches per minute to try to get a little bit past that, and now they just fall out perfectly. So that's 2 passes, 25 inches per minute, 100% power from both sides, and I can tell from the cut here. Well, I don't know if you could see in the camera, but it's going about 2/3 of the way on this one. So 25 inches per minute probably was a little bit slow. Yet it could have been a little faster. I mean, ideally you want it to kind of meet in the middle, but you do want them to fall out so you don't have to drill them out or chip anything. So that works pretty good. The alignment is good. There's just a little bit of a ridge in a couple spots, but not much, just a few thousandths of an inch, so that's acceptable. If I was just making these fresh for somebody that didn't have to match anything else, I'd just sand the top and stain these, and I'd leave the sides black because I kind of like the look of that. But I made a bunch of these about 20 years ago for the previous generation of the family, and so those were cut with a scroll saw and sanded, and so they had the nice oak color on the sides. So I'm going to sand the burn on the outside and the inside here, just to make those match a little bit better. So I'll show the final product when I'm done sanding here, but this works really well. So that reference on both sides with the frame that was in as part of the design, so that you get you're referring to pieces that are all within the same design page. That really works well. It's basically the same idea as having dowel pins drilled in by your spindle and flipping over and sitting on those spindle holes, or the dowel holes. But so that's a good way to get 3/4 of an inch with the laser really cleanly. This is a nice, perfectly straight cut. So I'm really happy with this. This probably would work with this 45 watt op laser. You could probably do that up to about an inch thick at least, because that laser will actually cut 3/4 of an inch all from one side. But once you get down to the last 1/8 inch or so, the beam starts to spread out and the quality isn't as good. And that's why I like doing this from both sides. So coming in a 1/2 inch, maybe even 5/8 from both sides would work just fine. So you can do 1 to 1 1/4 inch potentially even with this method. And then you could always sand it with a drum sand or something if you didn't like the looks of the edge. Okay, here they are all sanded down. I sanded the black off the edges, left the black in the letters because it's hard to get out there, and it actually looks better, I think, with the dark in there. Put a little bit of golden oak Danish oil on there just to match the previous ones I've made, and that's it. They turned out pretty good. Way faster to make them this way with the laser on the CNC than to cut them out with the scroll saw. The sanding I used the oscillating spindle sander to take the charcoal off the edges on the inside and the outside. Like I said, if I wasn't trying to match the previous ones, I probably would have left that black, sanded it lightly, and just sealed it up with some polyurethane or something so the charcoal doesn't come off easily. It actually looks pretty good, I think, with the black edges, but again, I had to try and match some previous ones I made, so I cleaned them up a little bit more. So anyway, this was a cool project. Hopefully give somebody some ideas what they can do with their laser if they need to cut thicker materials than that they can make than what they can cut from one side only. So this works pretty good. If you have any questions or comments, please leave them down in the comments section below.